So today we'll try to see what Parquet data is, data format. So, and where it is helpful, we'll try to learn a little bit about it, and then we'll try to see how to load and also work with Parquet data in Snowflake. So to start with, first let's just get some understanding of what Parquet data is and where it is, how it is used. So first of all, so it's a regular file format, just like how we have CSV, XLSX, TWB, etc. Right? So this is a file format, especially known to store data files. Okay, and this is an open source file format created and developed by the Apache systems. So this file format is normally known for a lot of benefits. We'll try to cover the important ones. So, but at the overall level, it is known to handle very complex data processing situations very better. Okay, so one of the main reasons this particular format of data storing is very popular and widely used is because of its data compression technologies that were used. So I will give you an example how it works and all, and how good it is at data compression at the end of the presentation. But it uses something called as, I might have already spoken about this in some of the previous session, it uses something called as columnar compression. So normally what it does is, so if you see any normal regular conventional databases like CSV or any other relational databases, they use something called as row-based storage. So what does that mean? If I have these three amounts of data, they will store the data as a row. So one row with all the different data types. So for example, here integer, string, and integer. So this is just a sample so that we have only two data types. But think of a situation where you are dealing with big data. You have literally tables that go up all the way up until 1 TB, 2 TBs of that much of data. So you have, if possible, thousands of different columns, and they have literally millions and millions of rows. So in that sort of a situation, storing row-based conventional database systems where you store based on row-wise is not very optimal. So if you look at our current online systems, right, AWS, cloud, all the cloud storage, you will be charged based on the how much storage you will be using on those online systems. So what these people have come up with is a new technology called columnar compression. So instead of storing at a row level, they will store all the columns put together. What is the advantage of storing based on columns? Because if you just store one column, all the elements in that column will have same data type, right? So irrespective, unlike when you're storing with the row level. So what does that result in is that when you compress a data file which is stored based on columnar approach, it will be able to compress far better, efficiently and effectively. So that way it will result in the greater reduction in the amount of storage that you actually need. So this is what most of the new technologies they keep using. Even our Snowflake that we have been going through, they also use columnar compression in the backend to keep to charge less from the consumers who use it. So Parquet file is also data format uses something called as columnar data storage when you store data in that format, so that the amount of storage that it actually needs is goes down. And how does this particular technology or this particular ability will help is that obviously it will be able to store in less amount of space, lot of data. And second, when the other important feature of Parquet data is that when you or in fact put it other way, the columnar technology is that you will be able to retrieve data and perform analytical queries very way better than. We'll also see how is it in comparison with the normal conventional. We'll see a quick example of that. So, but the reason why the data retrieval and the queries become the performance will be high is that normally, let's say, think of again the situation, big data, 1 TB, 2 TB data tables, right? So let's say you want to query certain columns. Of the thousands and thousands of columns, you have written a small query that selects only 10 columns. and of the millions of records that you have, you are only selecting hundreds or maybe 1,000 records, a certain time section or what subset of the data. When you have to do that sort of a data, what row-based storage technology will do is it will at least select all the columns for the subset of the rows that you have selected. So it will read a lot of data to only give you to use only some part of it to give you the result of your query. So what does that mean is it will read a lot of unwanted data for the queries that you write. So whereas that is completely avoided in the columnar storage. So here also, when we query and do any analytical tests on the data that is stored in columnar fashion, it will only look for accurately go to the data that you want and only read that data. Therefore, queries become much more faster. And secondly, the input-output load that you normally have in terms of reading and outputting, so that will also go down. So because of that, the performance will be high. So these are the main two highlights of a PARQUET data format. So one is you basically store the data very efficiently, and your performance will be very high for these two reasons, basically using the columnar technology. And apart from these two main, there are a few other advantages of PARQUET data type. So normally it can handle various different types of text encoding. So normally we use ETF8 more majorly, right? But there are several other text encodings, and PARQUET data format can handle almost all of those things. And apart from that, it can also handle complex data types. So normally integer, string, these are basic data types that we see conventional data systems handle. But PARQUET data type, you can deal with, there is some data type called maps. So and the documents, time series, images, videos, even all the complex nested data, it just not just handles it, but it handles it very well. So that is one of the other reason. That means it will no matter what data type you're dealing with, your performance is still will be very good. So that is these are the few major advantages of PARQUET data format. And normally this particular PARQUET data format, even though it's an open source, everyone can use it if they want to use this particular format. But it is predominantly widely used in the Apache software system. So these are all the software systems under Apache. So we have different softwares and tools for different tasks under the Apache Hadoop software system, and each of the software system you can easily work with PARQUET data. If you have PARQUET data, you can go ahead and use any of these tools on that data. Obviously, in this system there are other data formats also that are possible. So Avro is the data format that normally uses the row-based technology. So PARQUET uses column-based compression technology, whereas Avro uses the row-based compression technology. So even though it's widely used in the Apache cluster of software systems, but because of its advantages, all the cloud systems, major cloud service providers today also have given the support for this sort of a PARQUET system. So AWS, Microsoft, Google, all of them provide support, and currently Snowflake is also built on the same technology on which PARQUET data format was developed. So the same columnar compression technology. So we will get to that in detail maybe in some of next sessions, but we'll try to deal with it here. So now let's try to look at one interesting example of how effective this particular PARQUET data format can be, and how it can save time and money. So here we have a quick report on comparison between storing data as a CSV format and storing data as a Apache format. And obviously here if I forgot to mention, PARQUET data, its effects will seem to be very important when you're dealing with especially big data, large volumes of data, and also variety of data types, complex data types involved. So when you're dealing with that sort of data, PARQUET data, its effects will be way more higher. So if you see here, we have a CSV, 1 TB of data stored in CSV file format. Okay, when we try in Amazon S3, I'm sorry, I have to put it another way. So so we have some data, and that stored in CSV format is accounting to 1 TB data. Okay, and when we try to query that data in CSV, it is roughly taking about 232 seconds, and amount of data that it scanned of that 1 TB to give us our query results is about 1.15 TB. So I mean, a lot of intermediate data will be involved while scanning it. So, and the rough average online cost for this querying and storage is roughly estimated to be $5.75. But if you see data for Apache Parquet format, so the 1 TB has now reduced to 130 GB, which is almost like 13%, only 13% of the entire one, right? 87% less, and 236 seconds is reduced to 6.78 seconds. So the performance has improved by almost 34 times. And we can see the data scanned is also very less. It will only go to the data that you actually intended to use, and it will only scan that. So 99% less data is scanned. So and apparently the cost also, because of all this improvement, the cost also comes down to 99% savings. So these are the main advantages of Parquet data format. Now let's quickly move to the Snowflake and see how we can actually work with Parquet data in Snowflake. But before that, if you have any questions on the presentation so far on these 3 slides, you can let me know. Okay, let's move on to Snowflake then. Okay, so in the last session, we have seen how to work with JSON data. We have tried to load JSON data and pass it accordingly. We have, if you would recall, that we have used something called as a column with the variant data type. We first loaded the JSON file as it is in this variant data type, and then parsed it as a new table, which is neat and tidy, right? Now we'll try to load Parquet data, but we will try to use a different approach. We can use the same approach. You first create a variant data table, and then just load all the Parquet file into it and then parse accordingly. But normally this is not considered a best practice, but we will use something, a different approach for this handling Parquet data. So, and towards the end, we will also see if you have a normal conventional table like CSV file or normally a table in your SQL database, how do you convert that table into Parquet data format? So you can maybe use it for any other purposes. So we will cover those 2 elements today. So just give me a second. Let me close this. Okay. Right. So the first obvious step is we need to create a connector to where our Parquet data lies. So we have to create an external stage and specify that this stage will only read data type Parquet, right? So we will first create, first of all, we'll create a file format, and then we will use this file format to create the stage of Parquet. So we will first create this file format, and then we will go ahead and create the connector. So here we are creating a stage, and we are using this particular file format to set the property of the stage, please, as data format, Parquet format. So once this stage, so here is the S3 URL where my Parquet file is present, which we will be using today. And let me just show you that file. So this is the file name. So daily sales items .parquet. And so before that, so now I want to create the data, whatever the data that is there in this file, I want to create, extract it and load it into Snowflake as a table. But at the moment, there are a couple of issues. So for us, how can I open Parquet data? So if I want to create a table, I need to be able to see, hey, what columns are there in this particular file, so that I can create a table structure accordingly first. So that only then I will be able to load data from this file into that table, right? So one way to do that is, normally Parquet files, you need some sort of a third-party tool for you to open these files. If I open it in CSV or Excel or text editor, these things will not work. So, but Snowflake has provided some interesting mechanism here for us. Even before loading the data into our Snowflake, we can query the data directly from this connector. So that we get an idea of what kind of columns are there in that particular stage. So that we will directly use, just like you will take this one as consider this stage as a table and just query using the select statements. That's what I've done here. Select star from this particular stage, and it will take a few seconds. And yeah, so this is the data. So currently, if you can see, there are around 20 lakhs rows that were present in this format, and these are currently formatted like this. So I have few columns here called index level, category, date, department ID, etc., etc. So I'll try to parse these into a table and quickly see how I can do that. So first of all, a couple of things again. So here, if you would see, while creating the stage, I've specified that file format is PARQUET format. Only because of that, I was able to do this step. So if I won't specify the file format while creation of the stage, I cannot query it. So wherever you specify the file format, you will be able to do this sort of a mechanism. Even for not just for PARQUET, you can do this also for JSON data as well. So now let's say if you're not in a position to create this stage has already been created, but without specifying the file format. In that case, you can override the option. Let's say, for example, let's do that scenario as well. So now I'm creating the file format without specifying the creating the stage without specifying the file format that it is PARQUET. In this case also, I can be able to view the data. Only thing, I have to specify the file format property while querying the data from that stage. So this is the normal query, and I just specify in the brackets that, hey, please use this particular file format which I've created for the PARQUET data. So I'll just create this, and I'll get the same result of what data that is present in that stage. But for the time being, we'll just let me just show you that once. Yeah, so we can get the same data. But for the time being, we'll recreate this stage with file format mentioned. Okay. And let me pull back our query to see the data. Okay. So now what I'll do is I'll just copy these column names and create a table based on these column names. I can directly copy this, but I have already saved the code with me. So let me do that. So if you would see one thing here, when I loaded from that stage, the column, all the data is going into one single column, and Snowflake is categorizing, naming that column, aliasing that as, representing that column name as $1. So I will use the same name and call each and every element within that particular column, right? So all this will be one single column, and if I do run this thing, I will get a little formatted data in the form of a table. Yeah, so now I was able to get to a table, but I still see some issues. So column names are not properly aliased, and I also see these quotations in each of these values, which may be an issue. So I'll just format it slightly a step more, and we will be able to make it even more cleaner. So here I've just did the same select statement, but I've given some good column names, aliases. And secondly, I've converted the data type from the original data type into the whatever the right data type for that particular column. So this will be an integer. I've put this column as hobbies as string. And again, I've converted the date using the date function to a date. And likewise, I did for all. And now I should be able to get a cleaner representation of the PARQUET data which I had coded. Okay, so and there is one interesting thing that I will also show you quickly here. So this is the data that we have in the file. Now we can additionally add some other data as well if we are interested. So let's say, for example, currently we are loading in that stage where there is only one file and we are loading data from that file. But imagine if you have hundreds of different files and you want to identify, hey, this particular row of data is coming from which file name. Then in that case, you can also use a attribute called metadata. So you can just call metadata and $file name as file name, and this way, okay, I have to put metadata. I'll be able to get even the file from which that particular row record is coming from. I think
come on the previous line.
Correct. Yes. And there are quite a few metadata attributes that you can pull up like that. So within a file, you can also get what row it is, etc., etc. So currently, I can see the PARQUET data file that is being represented. So yeah, so I will now that you have all this table, all you have to do is copy this into a table. So I will not cover that. Now I'll move to the second step, which is if you have a data table that is already present in your Snowflake table, how do you convert that to PARQUET format? So let's say I have this table which is already present. This is something that which we have created in our previous. Okay, not this one. Let's pick something else. I have orders table, so let me So I have this data, 6,000 rows, and I will try to convert this table from this particular format to a PARQUET format. So for that, I will create one more additional stage, PARQUET stage, where I want to store the converted PARQUET data into, right? Here I'm not using any Amazon S3 URL. I'm just creating the PARQUET stage without any reference to any connector. But I'll just specify, hey, please use the PARQUET data format for this particular stage. Once I create this stage, I will just have to, it's a simple copy statement again to convert the regular data into PARQUET type. What I'm doing is, please copy into, instead of specifying any table name, I'm specifying this particular stage which I've created. Copy into this stage from this particular table. Select copy DB public orders from this table, and please convert this file data table into type format, okay, and keep the headers. So this is a simple statement, and I will execute this, and I can see 6,000 rows have been loaded into PARQUET stage. That means they have already converted. So I will quickly, I can check that using by querying that stage that which we have created. So if you would recall, so I'm using the stage we have created, I'm giving it alias T, and from that T, I'm calling the first column, the $1. And if I run this thing, I can see the orders table has been converted to PARQUET format. And so this is a better way of storing data. So let's say if you have a lot of data stored in tables, but it's not used regularly, but it's taking a lot of space, you can convert them into PARQUET data format, and so that way maybe this will be consuming less storage on your system, and it will eventually lead to lower cost. So yeah, so that's all I had for today. I will